Well, thank you everyone for coming to the last session of Past Summit. Yes, you can congratulate yourselves. I'm actually super excited. My big fear was that there would be no one here, but this is awesome. So I'm really excited to have a full room. I'm honored that you decided to end your summit experience with this session. It's one that I think is really cool. I'm biased though, but it's really a conglomeration of all the problems I've seen in the past 10 years of my developer life in helping other people solve their problems. So I'm hoping it will be beneficial to you. The last time you have to see this week. I'm sure we're all grateful for that. I'm not going to spend a lot of time here either, but I do just want to shout out local user groups more than anything else. I think they're really what hold the community together. So while this conference is great, after this session you'll go back home. If you're not already attending your local user groups, I highly recommend it. That's where you're going to meet people who you can see on a regular basis who can help you troubleshoot your problems, work through your problems. A lot of these examples in today's presentation I've talked through with people in my local user groups. I just think that's a fantastic resource that everyone should be taking advantage of. Quick background about me. My name is Bert Wagner. I guess most people in the SQL community know me for my YouTube channel. Every week I try to create some kind of video about SQL Server. It's usually programming or developer and performance type topics. And I try to make them pretty short and to the point. So they're not hour-long presentations every week. They're something you can easily watch while you're drinking coffee in the office, while you're getting ready to dive into your inbox of all those emails that you have to get through. So it allows you to continuously learn. YouTube doesn't pay the bills though, so I am a developer. I started out as a business intelligence developer. I still am a business intelligence developer, really. But I used to be more traditional SSRS, SSIS kind of focused. Now it's all about web applications and serverless development in the cloud. But the one thing that's kind of stuck with me through all those different types of tasks that I work on is SQL performance and making stuff run faster. And so that's where kind of the inspiration for this session came from. Session evaluations, please fill them out. Let me know what works, what doesn't work. It helps me out. Additionally, I heard someone say earlier this week that only 4% of people submit session evaluations, and at this point, I bet on Friday it's less than 4%. So if you're trying to win any of those prizes, like gift cards or past registration, this would be a good time to submit those evaluations. Well, not now, after the session, so you can let me know what you thought. All right, let's dive in. So today's discussion is about anti-patterns, and I just kind of wanted to talk about what patterns and anti-patterns mean in this context. A lot of times when you are working on something, especially if you're newer to that thing, whether it's a language or SQL Server, and you don't really know where to start, and you don't have guidance, one of the best things you can do is figure out what the best practice patterns are. So if the world is wide open and you don't know how to code something, try to figure out what recommendations and best practices are, so at least you have a starting point. Now, over time, you may determine that you have to deviate away from those best practices in certain scenarios, but as a whole, right, it's a good thing to follow. That's why patterns are up here. I got a nice picture of some trendy apartment, I guess, because it looks good. The flooring pattern is pleasant. What's not pleasant is the carpet in the second picture. That's more like an anti-pattern, right? And so anti-patterns are also patterns. They're practices, but instead of kind of being a good thing to do, they are typically things you want to avoid, right? They'll cause bad things to happen. They are very ugly things to do most of the time. And the thing with anti-patterns are that if you can learn how to recognize them, you'll become better developers, analysts, right, query writers, whatever you're doing, so that either A, when someone comes to you and asks you, hey, I need help troubleshooting my job, how do I get this thing to run faster, you'll be able to easily spot, like, oh, this part of the code looks like an anti-pattern, right? Let me start here to see if that's where the problem is. And two, maybe more importantly, is that when you're starting a new job, when you're building a new job out, you'll know to kind of avoid these patterns, these anti-patterns. So I think it's an important thing to learn, and it's something that honestly just takes time, right? You need to do it often, but that's why I created this session, is because I'm trying to, hopefully, if you're newer to this, try to teach you some of those anti-patterns up front so you don't have to struggle through it for years like I did. And just a quick show of hands, who here is not a DBA? Like they're a developer or an analyst or something? Awesome. Looks like the majority of you. Great, you are in the right place. Everyone else? I'm sure this will be beneficial too if you have to deal with developers or analysts or any of those people. So when we talk about anti-patterns and trying to figure out how to make our jobs run faster, the thing we want to look for are bottlenecks, right? So think of the highway. Here I think it's a 5-lane highway going in one direction and all the cars going on it, right? If there are a lot of cars on that highway and it's packed, but at least they're flowing all together and there's no major hiccups, that's good, right? You're still able to move, you're moving a lot of cars at once. That's really similar to how data processing works. Usually, we're working with lots of data, and we want to be able to process a lot of it at a time. And sometimes that will end up looking like our highway, right? We're doing a lot of work all at once, and that's a good thing. Now, the thing we want to avoid is like when on a highway, someone texts while driving and causes a car crash, and 4 of our lanes are shut down, leaving only 1 lane open, forcing all of our traffic to flow through that 1 lane. That bottleneck is really inefficient. And it could, if we are just able to remove it, tow that car away, solve that bottleneck in our analytical workload, we could make our jobs significantly faster for just a little bit of work. And so all the techniques and the anti-patterns we'll be talking about today, it's important that you find the bottleneck, right? You may see some of these anti-patterns, and you'll say, oh, Bert said that don't do this. This is a bad thing to do for performance. Well, if it's not actually causing you bad performance problems, don't focus on it, right? The key is figure out what the slowest part of your job, of your query, of your ETL is, and that's where you need to focus your time, because spending an hour troubleshooting down from 2 seconds to 1 second or half a second, in my opinion, isn't a really good use of time. You want to be able to find the one step, the one component that is truly your bottleneck, and focus all of your time on that. And so with that, we'll talk about 5 performance anti-patterns. And like I slightly mentioned at the beginning of this is from my own experience of writing some code and then looking at it 2 years later thinking, why did I ever write something like this? Has anyone ever felt like that with their code? Yeah. Right? You learn over time. But also, just being a good corporate citizen where I work, I help a lot of people out, and these are, for whatever reason, there's probably some high-ranking Google SEO link that people go to and they copy-paste some code, and it's just like, oh, why? That's the collection of this, where this comes from. So let's start. We're going to go through 5 anti-patterns today. So the first one is downloading data. I'm not talking about going to APIs to get some data or something that you actually need. What am I talking about? So imagine my company, I have a bunch of customers in a SQL database, right? It's my customer list. And I'm going to be running some kind of promotion, or maybe I'm at a conference and I'm collecting people's email addresses, and that's what exists in my Excel file there, or my CSV file. That Excel file is much smaller than my whole list of customers, obviously. And to be able to determine, who I'm going to run this promotion for, I need to be able to figure out which of these customers from my CSV file are existing customers, or at least maybe exist in my SQL database already. So there's a lot of different approaches we can take to kind of answer this question. For starters, if I only have 3 customers in that top CSV file, honestly, I wouldn't worry about building out an ETL or some kind of crazy automated process. I would just go pull those customer IDs or those email addresses or whatever that I'm storing in there. Let's say it's IDs. because that's what I used in this example. And I would just say where the ID is in, and then 1, 2, 3 for those 3 rows, right? That's the simplest thing to do. Makes sense to kind of do it that way. And then my query would return the right results, and we'd be good. Now, if I have some more customers in my CSV file, right, I could realistically just kind of keep listing them, hard code them into my in statement until I get the data that I need out of my SQL database. Once again, not a huge problem. Now, once we start getting more eligible customers, right, more customers that we collected on our list at the conference, at some point you're not going to want to hard code all of those into an in statement, right? And that's where automation comes in. So you might decide to use your favorite analytical tool of choice, right? It could be SSIS, it could be Python, R, right? Whatever you're using, it doesn't really matter. The concepts here all apply. And that's true of this whole presentation, by the way. I think I'd skip around between using like C# and some examples and stuff. These are language independent kind of anti-patterns, so don't get too focused on that. But imagine reading in your CSV file, reading in your SQL table of customers into, let's go with Python, and then you're joining that data, and eventually what happens is you output your CSV file of the customers that already exist in your database. Right? Works fine. It's a good way to do it. You do it once and you can rerun that job. The issue here, though, that sometimes happens is, let's say in your CSV file you have only 1,000 eligible customers. Okay, more customers than obviously you want to hard code into an in statement, but so we write a program to kind of ingest that into Python. Our SQL database, though, is, let's say, our table of customers is 10 million rows. So what happens when we bring that into Python? Well, if your computer is like mine, it may catch on fire. At least that's what it sounds like when all the fans start spinning and trying to join these 2 data sets. This is not a good way to join data, right? And once again, it doesn't matter, Python, R, whatever. If you are reading data into memory from your CSV file and reading in data into memory from your SQL server or other large data source, the application server or computer that you're doing that on is gonna have performance problems, especially if it's a low-powered workstation or laptop, just to be able to output 1,000 rows where you joined that data together. Instead, what you want to do is what the title of this slide has been alluding to all along. You want to move the smaller data. So instead of reading those 1,000 rows of eligible customers in our CSV file into Python memory, we would load them into SQL Server. Maybe a permanent table, maybe a temporary table, doesn't really matter, but you're moving that smaller data set into the location where the bigger data set exists. And then when you do your join, you can just write a SQL query that says join these 2 tables of data together. We'll take a look at that in a second. And the results of that query go from SQL into Python, and it's only 1,000 rows instead of 10 million rows that you're having to download. And that's going to make things run a lot faster. Once again, outputting your eventual 1,000 rows. So the key to all of this, right, is moving that smaller data. And so one way you can do this, right, you can accomplish this a lot of different ways, but the one way I typically do it is I create a temporary table. Right here, I'm creating eligible customers. And then you can do a bulk insert, or you can use whatever tool you're using to kind of ingest that CSV file into SQL Server, if that's where your larger data is. Sometimes that's not how you're going to do it. But in this case, SQL Server is larger. This gives us the benefit, too, of being able to do things like create indexes on that data to actually make our joins faster, to make sure that our sort order on our tables match between the 2 data sources that we're joining, and we're going to get better performance. And then finally, right, we write our select statement where we are joining those 2 tables of data together, and things will be much better. This pattern of kind of moving the smaller data, I mean, I've seen jobs go from literally hours to just a couple minutes, because a relational database system, for example, where that larger data is, will have an easier time joining the data. Not to mention all of the network traffic that you're eliminating by not moving 10 million rows of data across the network. So Any questions about that before we move on to the next one? Yes?
Where can I get that flame gift? I need that for a lot of my presentations at work.
Oh boy, I don't want to know what you're having to present at work that requires that flame GIF. But so this presentation's on the past site. I think they exported it to a PDF. But if you go to my website, it should be in the original PowerPoint. So you could steal it out of there. I don't remember where I got it. I may have made it for all I think I did make it. Okay. Any other questions? No. All right. Cool. Anti-pattern number 2, preventing index use. The picture of handcuffs is appropriate because either you or a database administrator or someone else has gone through all the trouble of tuning your queries and adding indexes and trying to make performance fast, and you're essentially shooting yourself in the foot by preventing those indexes from being used. So let's see, how do we prevent indexes from being used? For starters, right, select star. So if we have this query on the left saying select star from customer where ID equals 123, because we are selecting all of the data in our table, in our customer table, SQL Server is going to have to do a clustered index seek. And now, if our customer table is 100 columns wide, and we only really care about returning two columns, SQL Server is still going to actually return all 100 columns of data. That's particularly problematic if you have some really large columns in your customer table, right? That maybe are nvarchar max or something like that. Then performance is really going to be terrible. So even though, right, you may have learned at some point that seeks are good, this type of seek where you're returning too much unnecessary information is really a bad thing. The alternative, right, is obvious. Just don't use select star. Only select the columns you need. And this is really important if you are a developer, for example. If you use an ORM, I love ORMs. I know some DBAs don't like them and stuff. I think there's good and bad use cases for it, but you need to be careful if you are using ORMs to specify which fields you select. Because if you're not, you're going to get that first scenario. Instead of select star, it's just going to actually list out every column name. But it's the same effect. You're bringing back way more data over the network than you need. And in this case, where it's one row, who cares? Unless you have some really wide columns. But especially if you're bringing back more than one record, that's going to be really painful and slow things down. Converting data on read. So this is kind of where we get to sargeability. And sargeability just being the ability for SQL Server to use an index and seek on that index. So in this first example, we're once again selecting from customer. And we have our column in our database purchase date stored as like a date time or date time 2. But we want to compare it to a string, so smart us. We're going to say cast purchase date as char10 because we want to be very explicit with what we're doing. Well, the issue that happens there is since SQL Server has that data as date time 2, for every single row where it's going to have to do that comparison on purchase date, it's going to have to do a conversion. And that's actually what that little exclamation mark warning sign on our select statement is saying. If you were to hover over that in your execution plan, it would be saying that, hey, you're doing a lot of casts, a lot of transformations, and it's preventing me from being able to do anything. And that's why our operator there on the right is a index scan. And that's too bad, right? Because hopefully, I'm assuming in our table, we have lots of records and only a small subset of them match that date that we're looking for. So instead of doing any kind of transformation to the column side of your predicate, you want to try to do any kind of transformations you want one time. In this case, on the non-column side of your predicate, right? So you could say something like cast this date string as date time 2, and then match on that. Now, yes, you can just type in the string without any casts as well, but just be aware that SQL Server will transform things on your behalf if it needs to, right? Whenever you are comparing data in SQL Server or joining data, data types have to match. And so to make database easier to use, SQL Server will automatically convert data types to you, so they will match when it's able to. But whether it does it automatically, or also known as implicitly, or if you specify it like this, just be aware that those data types are being converted. So in this case, in our bottom example, since we're not transforming the data on the column side of our predicate, SQL Server is able to do a seek. It's able to use that index, which is storing that data in that order that we're interested in, and be able to just navigate directly to the data it wants. So similar to our explicit casting, changing of data type, these same problems happen with scalar functions, right? I've seen lots of date logic like this, where you may have something saying, hey, I want to find all customers who bought something in the past 30 days. And so you say, oh, great, there's a date add function, or whatever else in the relevant database you're using, and you're doing that transformation on the purchase, on the column side of your predicate. This works exactly the same way as that previous slide. SQL Server is going to have to do that transformation on every single row, and it's not going to be able to seek to the rows, where it finds that date. Instead, if you do have to use a scalar function, do it on the non-column side, on the static side of your predicates, and SQL Server will be able to utilize those indexes. Implicit conversions, right? So I alluded to this a little bit too. When SQL Server has to do a join, it has to make sure that those data types match. And so in this example, I have two tables, customer and customer details. And the ID column in that first table is an integer. And in the second column, it's a varchar. And so in my query, I'm joining on those columns on the ID fields. And this is the execution plan I get. And you can see, once again, we get a little warning exclamation point on our select telling us there is something to be concerned about potentially. But we're also having SQL Server have to do an implicit conversion to get those data types to match to be able to do that join, affecting performance. Now, you'll notice if I change the data types to match in my table definition, so both my ID columns are ints, we're going to get a different execution plan where it doesn't have to do that computation of changing the data types to be able to actually do the join. And essentially, whenever you're writing queries, right, you want to try to make data types match because it's just going to be easier for SQL Server to do it. And if you don't, it'll do it on its own, and you may get bad performance. I find this in my world particularly relevant when I'm working with a data warehouse, right, that maybe someone else built. And they indexed it thinking about how people will use that data. And you may have two values or two columns for really the same value. You maybe have a policy number, for example, that is of a varchar data type. Maybe it has some leading zeros in it or something like that. And then you have the integer equivalent of that data type. But if you actually go on that table and look at the indexes on it, maybe only one of those columns is actually indexed. So if you're writing your query, you may think, oh, I'm just going to write my query against the integer form of a policy number, because that's what's easier for me to type in. I don't have to add 15 zeros or whatever in front of it. But if your index is on the column that is the varchar data type, it would be much better for you to actually take the time to type in those extra zeros to make sure that you're typing in a string so that it can utilize that index. Otherwise, it won't. So just something to be aware of. All right, moving along, anti-pattern number 3. So you can see the picture here is someone's very nicely organized garage of tools. So I actually like woodworking too. And I have a lot of woodworking tools. And one in particular, right, one tool in particular is called a chisel, right? It's used for taking, chunks of wood out of other chunks of wood. And I have this really nice set of chisels. They're old. I've taken the time to condition them, sharpen them, make sure they're beautiful. I mean, you can see a reflection in the blade because of how sharp they are and how I've polished them. And I love these tools. I take very good care of them because I use them only for very precise work when I'm building furniture. Now, I also have another set of chisels. Right? It's the same tool, but I bought these at a garage sale. And they're rusty, and they've got chunks out of the blade taken out, and they are just a complete mess. But they're also really good tools. they're not good for the furniture making that I do. There's no way I'd be getting really terrible cuts unless I took the time to rebuild them. But they are really good for things like taking door hinge pins out and destroying something if I'm doing demolition in my house because I'm doing a remodel. They're great for that. They're great through putting holes through the wall, right, if I need to take down some drywall. The point of this, right, is that both of these tools, both of these sets of chisels, right, they're the same thing. They're chisels. But one of them is used for one very specific purpose, and the other is used for a very different purpose. And this happens in the software world, right, in the tools that we use as well. So you want to make sure that you use the right tool for the job, even if there are multiple tools that can do the same thing. So let's talk about joining. A few minutes ago, right, we saw this slide with the cool flame animations. We talked about how, yeah, you can join your data in Python, but it's probably not going to be a very good place to do it if you want fast performance, especially if your data is living over in SQL Server. Now, if your data is already on your hard drive with those 10 million rows in a CSV file, Python's a great place to do it. It's probably faster than moving everything into SQL Server. We also talked about implicit conversions, how if you don't get your data types right, SQL Server may have to convert things behind the scenes and things will be slow. So the takeaway here is, right, there's lots of ways to join your data. And the thing you want to be careful of is just thinking about where to do that. Like I mentioned, if all of your data is on your machine where Python is installed, then great, right? Read it into memory in Python and whatever, use pandas or a data frame. I'm not an expert Python developer here, but you can just do the join there. It's probably going to be faster than moving it off to somewhere, right, if this is like a one-time ad hoc thing. But if your data is somewhere else, like SQL Server, think about using it there, especially if the data that's already in SQL Server has things like indexes available. Those indexes are going to help speed things up and make things run faster if you're able to utilize them. And same thing, right? Make sure your data types match when joining, because otherwise some of these tools will do better jobs than others in getting that to work. Let's go on to filtering. So in SQL Server, we can write a query like this. Right? We're selecting some rows of data out of our orders table where purchase date equals the 1st of January. This filter in SQL Server, assuming our data is indexed correctly, right, will result in an index seek where SQL Server will return, a handful of rows compared to the whole size of that table. If our table's, 1 million rows, maybe it's only going to return a few dozen rows for that date. So SQL Server is obviously very good at doing that. It's going to read 5,000 rows and return 5,000 rows, roughly. I say roughly because I know Hugo's sitting here in the front row. I'm afraid of saying anything wrong. So alternatively, here's the C# part of the presentation. If you're not used to C#, don't worry about it. It's OK. You're probably familiar with just a general-looking loop. So we could, instead of filtering our data in SQL Server, we could read all our data into C#, right, and iterate over a table. And then for each row of that table, find our column, right, called purchase date, and just do an equality comparison to see if that value equals the 1st of January. And then if it is, right, output that row to something. The problem with that, of course, is that we're not just reading 5,000 rows, right? We're outputting 5,000 rows. But in order to do that, we still have to iterate over all 10 million rows. So looping over data in that manner is really slow. Unless, of course, right, your application server is just way higher powered than your SQL server. So you're good to go. I don't know what that means, Kenneth. All right, aggregations. This is another thing, right? So in that last example, we saw how SQL Server, right, because our data is indexed, and most likely, right, your database server is much more powerful than your own little workstation or your application server, is going to be much better at filtering data than your laptop would be. The same thing's true of aggregations, right? So here we have some C# code. We're enumerating over a data table and we want to get a sum and an average, right? Basic stuff. We can assume our read-in data from database function there is just reading in all of our rows and then having to enumerate over them. It's going to be just as slow, right, as our previous example, because it's going to have to read over all those values and add them all up manually. Not to mention, right, this isn't factoring in the fact that you are having to transfer 10 million rows of data over the network into your application to actually do those summations and aggregations. On the other hand, you can do that same kind of analytical work directly in SQL Server. So this is just something I see a lot of people who maybe are used to using more statistical tools like R or anything like that. It's like, yeah, R is great at taking, returning averages and means and things like that, but only if your data is already there. If you're dealing with lots of data and you have to move it all into R's memory space to be able to actually do whatever basic statistical aggregation that you want to do, that's going to be really painful. And you could do that same thing in SQL Server, and especially, right, if you're doing lots of aggregations, hopefully you're using column store indexes because those aggregations are going to be so much faster when compared to having to move all of that data over the network to your application to do them there. Any questions about that so far? All right. Yes?
I just wanted to add about the joining part.
Mm-hmm.
It also comes into play. I know we shouldn't use it, but I'm using it extensively, having a linked server on the OLTP system and expecting to the data warehouse system, and you might occasionally to see if you've got everything transferred, join the both,
Mm-hmm.
and to see where does it really make sense to execute the query and where does the linked server query run, because the linked server query does something quite similar to R. I think it just takes a select star, shuttles the data over to another server, and then it was there.
Yeah, so to rephrase, I guess your question or statement, right? It's just that when you're using linked servers behind the scenes, you're saying, right, they're just doing basically a select star. And sometimes at some point, right, if you're moving data between servers, it's just a fact of life. You're going to have to deal with network I/O, that you're moving a lot of data. If you're able to filter some of that data at the source, right, then you're going to be doing much better than if you're moving all that data and filtering it afterwards. That's the big overarching goal of this section, is try to filter that data down, right, in the right place, wherever that may be. Cool. All right, window and analytical functions. So these are really cool. I like bringing these up in this presentation because oftentimes the audience isn't as familiar with them. But they're really handy. A lot of times the type of statistical work that I see people doing, or at least the preparation for the statistical work that they need to do, right, is calculating things like running totals and needing to be able to kind of see values across rows. And SQL Server is able to do a lot of that work for you, which makes it a lot faster if you're able to do that work on the billion rows of data in your database instead of having to bring it over once again in your application and do it there. So just like as an overview, if you're unfamiliar with window functions, who here has not used a window function? Or be honest. OK, enough people to make this worth it. Cool. So the idea here is that you're able to pick a window that you're defining by this partition by statement. So you can see we're doing a sum of our total over our window outlined by partition by. So we can add these highlights to kind of give you a visual representation of how that works. And so we're partitioning by customer ID. So every time that customer ID changes, that's a new window in SQL Server's mind. And we're saying, OK, give me the sum ordered by purchase date. So that's going to give us a running total. So you can see, hopefully that's big enough. I like that this room is not too deep, but wide instead. You can see on row 2, right, we've added 5 to 18, and we have 13 for the running total. Add 3, you get 16, so far, so forth. You can do things like that, calculations spanning multiple rows with a window function like that. Additionally, right, there are some aggregation functions, or analytical functions rather, like lead and last value, which can let you read multiple, what does the next row of data look like, or what's the previous row of data, right? If I need to find a difference in values between two rows, I could get the next row's value and then, compute that, do the subtraction or add it or whatever you're trying to do. Right, this isn't a session on how to use window functions and these analytical functions, but I want to point this out because I often see, right, people are used to the tools that they use. And if you're working with large databases, large data warehouses, and you're moving all this data into your tool just to calculate a running total, that's really painful. If you want to make the performance of that run a lot faster, use the tools that are available at your data source because they'll be able to do it just as well, and you'll get the performance benefit of not moving that data over the network. Additionally, right, usually your SQL Server will be more beefy than your own workstation, so it should run faster too. The downside there is, right, if we have DBAs in the audience, that you are now performing all these computationally heavy queries on the SQL Server, which you're paying a lot of licensing for. That's just the balance. That's how, there's trade-offs. You got to pick where to do this stuff. Let's talk about sorting, because if the DBAs in the room weren't angry about that last one, they might be about this one. We could sort data lots of places. Sorting generally, right, in programming is a very expensive thing to do. It takes a lot of time. But if we need to have our data sorted, we could do it just using an order by statement. And honestly, that's not that bad if our data is already mostly sorted, right, from something like an index. Doing that type of operation is actually going to be really quick in SQL Server or whatever other relational database you're using, because that index is already storing that data mostly in the sorted order. But you always want to specify with order by just to ensure it. But if it's already 99% of the way there, it's going to give you that data back really quickly, and it'll be very fast. If SQL Server doesn't have an index to help it, it's going to have to use that sort operator, which is very expensive to use. But once again, this is where you have these trade-offs of, do you do this on the beefy server, or do you do this on your little laptop? Doing it on the server will be faster, but expensive for licensing reasons. But if you truly need to get it done, it's a good place to get it done. Just be aware of all the resources that you are potentially using on the server when doing that. And think about it. I mean, this query, for example, I would hope you're never returning all of the orders table without any filters. You need that sorted. Hopefully, you'd be doing additional steps. All right. So common table expressions. This is another feature in SQL Server that I think is really handy, especially for analysts and for developers who maybe, obviously you know how to write SQL queries, but you're still new. You're kind of feeling it out how to write things. And if you write a big query, maybe it gets a little complicated. So this is my example of a complicated query that could fit on a slide. It's not that complicated, but it's got some where clauses, some subqueries, some joins. Imagine this is much bigger, right? And you get those monster queries that are really complicated. So common table expressions, we're not really going to give you a performance benefit most of the time. They actually will maybe make it more detrimental, potentially because it may confuse the optimizer if they get too big. But they're an easy way to help you write complicated queries, right? So what I don't want you doing is writing your Python job to read in the entire orders table, and then the next step of your Python job, read in the entire customers table, and then you're going to do your join in Python, and then you're going to filter that data afterwards because it's easy to break that process down into steps, right? I know as a developer myself, before I started using SQL Server, that's how I would build something because it's easy, right? You could kind of break it down into one step at a time. Common table expressions are the same way to do that in SQL Server, at least from the writing aspect of it. So it'll make the logic easier, but it'll give you better performance, hopefully, than doing that in Python or R or wherever else. So if we were to rewrite this query, we can just use the syntax with, and then we give it a name, that's expression, a name, new customer. So you can think of each of these sections we're going to look at between these parentheses as like a data set or as a table. Now, using a CTE will not do anything special. It's not actually creating temporary tables. It's not doing anything different. It's just a handy syntax that'll later get converted to the same thing that would appear on the left in most scenarios by SQL Server. So this is purely a tool to help you manage writing complicated queries. It also allows you to write recursive queries, but we're not going to get into that today. So here, right, we break our first expression down into new customers, so we're just selecting the customers that joined in the past year. Easy enough. We create a new expression of recent purchases. So we just take our purchases from our orders table of the past day, or the past month, sorry. Then we define an expression for online orders only. So we have an easy table join in there, an easy where filter, right? So far, all of these components, there's nothing difficult about any of these queries. And then at the end, we can just combine them all together. I want to reiterate this. There's no performance benefit, usually, to doing things this way. And there is possibility of the performance actually being worse. So what I usually see happen is people will start with CTEs because they are easy to use, and I love them. This is how I start. I always start writing a CTE kind of like this, top to bottom. And I keep adding parts, adding parts, adding parts until SQL Server just explodes, right? Like eventually you'll experience it'll run, and then you add one more common table expression, and it's going to just blow up and take forever. Eventually, it just becomes too complicated for SQL Server to kind of transform your expressions into a normal query. But at that point, you can, for example, and we'll get to this in a little bit, take those results, store them in a temp table, right, and then continue on from that temp table. I'll go into more details, but this common table expressions are just a great tool for helping you learn how to write more complicated queries, if that's something you're new to. Any questions before we go to the next section? No? Great. It's the first time I see more people coming into my session instead of leaving as the session goes on. So I am super impressed with everybody. Oh. Ouch, my heart. All right, we're just going to say that one balances out. That balances out. I know Ginger. Thank you. All right. Anti-pattern number 4, looping. This is a huge one. If you're coming from a development standpoint, this is one that will just make your queries terrible if you are not aware of how set-based operations work. So hopefully, this is one of those things, right? And I'm seeing less and less of it, which makes me think that people are more aware of it, but I want to just bring it up because as a developer, when I need to iterate over something, I will use a loop. And SQL Server lets you write loops, lets you write while loops using cursors. And so you can do this, and it'll work, and it'll give you the right results, but it's going to be very painful. This is kind of the developer mindset of getting data, right? So we're selecting all our data from orders, and then for each order, we're going to go out and get our order details. We don't want to do that, right? We want to use the functionality that's built in, that databases are good at, which is these kinds of relations where we're using joins. And cursors are just kind of the most obvious form of looping in SQL Server. There's other types of looping that happen internally, which we'll see, but there's almost no reason to ever use cursor loops unless you're doing something like you're running some kind of maintenance script across all your databases or something like that. If you're coming from that developer mindset of writing loops, you need to switch to kind of using these set-based operations of using the functionality that exists in a relational database to do your joins. Eager lazy loading. This is one of those ORM concepts, but it applies. A lot of people probably do it. They're not aware they're doing it in their code. So once again, we'll get the C# here. Imagine we have a query that gets all our orders. And then once again, we're now doing the same kind of loop we just saw in our cursor, but for each order, we're going to run another query to get order details. That's what that get order details method is doing. So for each row in one table, we're going to go call another query. If our orders table has 100 rows, we're going to execute 100 queries to get the details of those orders. If it's got 1,000,000 rows, it means we're going to be executing 1,000,000 queries. Not good for performance. Once again, do that in SQL Server. And all of these ideas, right, combine. Not only are you going to get better performance by not iterating over a loop to run 1,000 queries, you're also going to be able to potentially move less data across the network rather than having to call the same thing over and over again. You're just going to run that command once and bring that data into your program right up front, right off the bat. Correlated subqueries are another example of looping, even though people may sometimes not think about them. So in this example on the left, I'm getting an average for each order, right? I'm combining the totals for each item in my order and then returning that, one per order. And I'm not really sure. I don't know. This is one of those things that I personally have never had trouble with this, so I have trouble understanding why people write queries this way, but it's something that I see all the time, where we're putting the select statement inside parentheses, inside another select. And what is happening in SQL Server when you do this is it will actually execute that query lots of times. So if we look at the stats IO for this is telling us how many reads we're doing. Here we can see our logical reads are 12 for our order details table. Essentially, we're going to hit that table 12 times. Instead, if we just rewrite our query to get our average total for an order, and we join on that, right, taking that subquery out of our select and just putting it in our from. Literally, I think the entire subquery itself is basically the same. We're just getting rid of our where clause and putting it a couple lines down. That's going to give us better performance. In this case, right, for this example, very little data. We only had 2 logical reads. But when you start working on much larger tables, this becomes a huge performance issue. And the thing to be aware of is not every single query that you will write that is a correlated subquery can be rewritten this way, but the vast majority that I see are easily rewritten. So definitely try doing that. OK. Finally, anti-patterns. So writing queries once. Who here has ever struggled to write a query or a program? All right, good. I was hoping everyone. I definitely do. So what usually happens? You write your query or you write your code, and it's not working. You're getting errors. You're Googling. You're going on Stack Overflow. You're trying to figure out how to get it to work. And you finally get it to work. Maybe you spend all day getting this thing to work. You get it to work, and then you're like, thank goodness, I'm moving on to the next thing. I get why that can give you a sense of relief. It's a good thing. But usually the first way you build something, unless you're really lucky, is it's rarely the best way. So while you may be happy that you got it working, it's usually a good idea, especially if it's a high performance kind of scenario, to look into your queries to see if there are other ways to write them. So what am I talking about? And I look at Hugo. I think you've had debates online about this, of distinct versus group by. Am I? No? Possible.
There's a lot of things I have.
So if you cannot get the query optimizer to get you an execution plan that returns your data quickly, right? What are your options, right? You can do things like change your indexes and performance tune and probably all these things you learn about the conference. But sometimes, at least in my career, right, I won't have access to those things on a database. The only thing I can do, and the only tool I have available, is to actually rewrite the query itself. So there's a lot of ways to rewrite the logic of a query to get the same thing to happen. And so one kind of rewrite that commonly will get you the same data is doing a distinct versus a group by. Now, this will not work for all queries because these two commands are not necessarily always doing the same exact thing. But in some queries, like this one here, I can say select distinct, these two columns from my table, or I can say select these two columns from my table and group by those two columns. And they will logically return the same exact rows. I get the same exact result. The interesting thing is that SQL Server will not necessarily perform these two operations using the same methods. And so when you're dealing with real-world data where sometimes some things just don't work like you want them to, rewriting a query to get the same result, you can trick the optimizer into giving you a different plan. And so this is one of those options. And so for this whole section, what I'm going to show you is in a lot of cases, these queries are equivalent, but you need to be sure to test to make sure the results are the same. If anyone saw Panal's presentation from earlier today, he used lots of examples of rewriting queries. He used an example from you, Hugo, that was great, about rewriting queries to get the optimizer to give you different plans. But the problem is sometimes they won't always give you the same results, so you just need to test. ORs versus union alls are another example. Sometimes when you write a query and you use an OR clause to compare two values, like I want to return rows where column 1 equals A or column 2 equals A, that may work. But sometimes that'll give you bad performance. And what may give you better performance is to rewrite the query as two separate queries with just a union all between them. This will give you, logically, the same exact result. You may need to deduplicate values potentially or something like that. That's why you should test. But most of the time, SQL Server will give you, well, in this case, I think almost all the time, SQL Server will give you a very different execution plan, and you may experience very different performance. So, and it works in reverse too, right? If you have queries with union alls, maybe it's better to rewrite them with ORs, and SQL Server will be faster. There's no way to tell without testing, right? These are just kind of general things to look for. Not in versus not exists. This is another example where usually using not exists will be faster. I'm sorry. Usually there is no difference in performance, except in some scenarios, not exist will be faster. But it's generally safer just to always use not exist, because if that performance benefit exists, then you'll receive that benefit. And if not, that's OK. You'll still get the same data. It's just one of those things where the SQL Server optimizer is going to change how it's working internally to retrieve this data for you, and so you may get vastly different performance. Another example is just changing out the way you do joins. Sometimes, if you do inner joins, you'll get one type of joining operation in one way that SQL Server is delivering the data to you. But other times, you could do something like a left join and then just filter out your nulls later in the where statement. These are just ideas. These aren't the end-all, be-all ways of rewriting queries. They're just there to kind of get you thinking about, OK, if my query is performing slowly, what are some other ways I can rewrite my query to give me the same exact thing? There's lots of ways to do this. It's just a matter of trying them to see if the performance matters. But once again, don't waste your time on doing this stuff unless your query is slow in the first place, unless you like exploring and learning why that happens. Correlated sub queries versus joins are another example of this. Right? We talked about how correlated sub queries can be very bad for performance, and we saw an example of that with our number of reads. Oftentimes, it's very easy to just rewrite them like this in a lot of cases. Forcing join order. This is a trick I first saw from a presentation that Adam Mechanic did at SQL Bits. There's a recording of it online. If this is something that is interesting to you, he's got a whole hour-long presentation on it, which is really good. I recommend it. But this is a trick that I have used on databases, right? So I work with this one data warehouse that contains a lot of data that just gets hammered all day long with really expensive queries. And it's very important to the business. The problem with that is making any kind of change to that data warehouse is also very slow and tedious to get that change approved because it would require lots of testing and it affects so many different systems, right, that it's hard to do. So sometimes when queries are running slowly, I can't just say, oh, I want to add an index, or oh, let's change this or that. The only thing I can do is use these kind of rewriting tricks to be able to get things to run in a different way. And so in this example, on the left, right, starting on the left, my original query is joining 3 tables together. Now, I, as the user, know this data, and I know that table 2 and 3 should get joined together first, because that's going to reduce the result set significantly so that when I later join it back to table 1, it'll be faster. But for whatever reason, the optimizer of my database isn't doing that, right? So quick reminder, SQL is a declarative language. You just kind of tell it what to do, and it decides how to do it for you. So even though I list my tables in my from clause as table 1, join with table 2, join with table 3, SQL Server may decide to join them in any order it wants. And it doesn't matter the number of parentheses you add around those table joins or changing the order of the table names. SQL Server is going to do whatever it thinks best. And sometimes what it thinks best is entirely wrong. And once again, there are better ways you should fix this problem. Yes?
Are there any differences in writing it this way rather than just using the force order option?
By using what option, sorry?
The force order option?
We will get to that. Yeah, so the question is there any benefit to doing it this way versus the force order option? So the force order is a hint which will force your tables to run in the specific order that you specify using it. Yeah, and sometimes that might be better. Sometimes this way may be better. It may generate still different plans because I'll explain what this is doing here in a second. But going back to the left, right, you have no control over what SQL Server is doing or any relational database engine is typically doing. So even though if you know table 2 and 3 should join first, it may decide to join table 1 and table 3 or table 1 and table 2. And that could lead to really bad performance. Best solution is updating indexes, updating statistics, so it has a better understanding of what those tables of data look like and the data in them. But if that's not a solution, what you have to do is you kind of have to use a trick. And so in the second example, what we're doing is we are building a subquery of table 2 and table 3, and we're adding a blocking operator into it, in this case, a top. So when SQL Server sees that top, it's going to have to say, OK, well, I need to join these 2 tables together first and then pick the top X number of rows. But you'll notice X in this case is 2 billion and change. And so the reason to use a big number like that is it just kind of sticks out, right? It's not something easy like, oh, select top 1,000. Maybe that's part of the business logic of this query. No. If someone sees select top 2 billion, whatever there, I think that's the max value of an int. Something, right, that should draw your eye that, hey, there's something funny going on here. And if you ever use this, you should definitely document this better than just my 2 little quick lines of comments. But what happens is SQL Server is going to take those 2 tables, join them together first because it thinks it's going to have to bring back some reduced number of rows. Instead, what happens is since you put some large number after your top, it's going to return all the rows. But you've accomplished what you wanted, which is to join these 2 tables together first. And then, right, it'll go on and join table 1. Gentleman in the audience asked about the force order hint, the force join order hint, which will also force the join order. You can use that. So I'm really against hints in general in long-term code. What I'm thinking of here that could possibly happen, right, is as these tables, as the data evolves in these tables, as the statistics get updated, with this solution, yeah, you're forcing SQL Server to do one thing, but most of the operations will still remain the same. I'd be afraid of using a hint because over time, as the data changes, it may give you different results. I don't know if anyone has other thoughts about that, some of the experts, but. Yes?
Well, it's a related way that I've been able to force join order is using table valued functions. And so you cross-apply to a table valued function. So like if you have a really big table that I had a really big table I couldn't load into memory, so I would start with that table, but I would cross-apply the others. Except I know I've heard other challenges with table valued functions, but hopefully those are going away with 2019.
No, so I love that, right? And yeah, what you're describing sounds terrible to most people, but I think it's really cool because, okay, so table value functions have a lot of problems because in the past, right, the cardinality estimator would just assume there's 100 rows or one row coming from them, right, and that would lead to problems. In 2019, that gets expanded. Whether it works consistently or not, I don't know. I haven't tested it. Hugo's shaking his head no, so we will still be dealing with table value issues. But yeah, that's the right idea, right? And I can't tell you if what you're doing is good or bad, but that's the kind of creative stuff that you sometimes have to come up with, which is ugly and whatever. But if you can trick the optimizer into doing something else, and it is actually faster than what the optimizer would do normally, then, I mean, sometimes that's what you have to do. It's digging yourself out of a worst case scenario. So I've heard other people use that kind of technique as well. I think it's valid. You just got to be careful with it that you're not, ultimately going to do something really bad. Just test. Yes?
The nice thing about using the row goals technique is that you don't have to force join order for every join. So I've got a case where I've got a CTE of about 8 or 10 tables that I need to join. I don't care which order the optimizer joins those, but I want that pack to be joined and then come out into the rest of the query.
Yeah, thank you. So I forgot the force join order, right, is on a per query level. So like this gentleman said, if you have several tables there and you don't really care, you're okay with the optimizer picking which tables to join the orders in, except for these two that you constantly have problems with, that's one way around it. Thank you.
Like you said earlier, it really comes down to you just got to test.
Yeah, these are all terrible things to do, right? Let's be very clear. This is like the last thing you ever want to have to do in your queries. But I have often had to do these things where I have no other choice, right? And it's not like the DBA's fault that they're not fixing it or whatever. It's just sometimes you get put into these scenarios and you have to get yourself out of them. And so knowing these types of tricks, you're not going to use this all the time, right? But for those times where you can't do anything else and you have a query that's running, for 45 minutes and you need to get it quicker, right? Try these kinds of creative rewrites because they might help you. Ultimately, try to go back and then solve the root cause, the underlying problem. But if you need to get out of something in a pinch, I think these are helpful. Anything else before we move on? We got a few more. Oh, yeah.
Microsoft is continually improving the optimizer, and they try to look for different queries that mean the same thing. So a trick that might work now might not work so well in the future, maybe. So speaking as the DBA, I'd rather see a hint if the hint does what you need it to do.
Okay.
See, and I would say the opposite.
Okay.
Well, because the data evolves, so with a hint, you're forcing it into a specific path. With something like this, like you said, Microsoft's constantly evolving, and it might change, but the data is changing as well, so you're giving the optimizer the opportunity to do more, whereas with a hint, you're kind of bottlenecking it, into it, or you're forcing it down a specific path, and it'll never change.
Well, it'll never change the part that you've hinted anyway.
Yeah.
Yeah, but I guess it all assumes if you think that's the right thing or not.
Yep.
But, yeah,
I mean, it comes down to your code should be reviewed and refactored on a regular basis because data changes, code changes, versions change.
Yes, exactly.
Every time you use something like this or a hint, you should retest after every CU.
Yeah.
Because it might not be good anymore.
After a new CE, is that what you said?
After every CU
anytime you use any of these tricks, right, you should really document them because they are tricks. That's exactly what they are. But they are tricks that work in a lot of scenarios. So yeah, after you install new updates, especially right when new cardinality estimators come out, which I know isn't very often, but it's when the last one came out. I mean, a lot of stuff changed that force how the optimizer thinks about the data that it's dealing with. So always good to review that. Thanks. All right, one last example. Right, I kind of talked about this a little earlier on about the CTE example. At some point, you're going to be writing these CTEs. They're going to make your life a lot easier because you can kind of break up complex queries into these small parts. But like I said, once you get so many levels deep, SQL Server may decide, it'll just have a hard time figuring it out. Do you have something? So in those cases, what you can do, right, is just take your results of where your common table expressions are running well, stage that data into something like a temporary table. You can then even re-index it if you need to do it in a different order, and then continue on from that point. This doesn't only work with CTEs, right? This could just work with large queries in general. You have to remember that the optimizer, it does its best, but when you throw a gigantic monster query at it, every step along the way, when it's reducing data or joining new data together, it loses information. And so once you do enough transformations, it's just kind of flying blind, right? It thinks it has an idea of what the data looks like and things like that, but it can start making really bad performance decisions. And so a lot of times with those giant monster queries or with CTEs like this that are many levels deep, a good technique is to just say, hey, I'm going to stage this data in a temp table right now, because up to this point, everything runs real quick. And when I stage that data in a temp table and do things like create an index on that temp table, SQL Server now has all this new information and all this new metadata about that staged data that can then run the rest of your query much more efficiently. It will at least have a much better chance of creating a plan that will be more efficient. Kenneth, did you have some?
Very similar to what you were just saying. I was going to say that I'll get the same thing when it's a really large query.
Yep.
And if the optimizer can't finish optimizing because it's just too many possibilities, then sometimes pulling a piece of that out into a temp table will help.
Yep.
Sometimes it makes it worse.
Sometimes it makes it worse, right? You got to test all these changes, but that brings another point, right? With those large queries, often the optimizer's step of trying to find a good plan, it'll just time out, right? And you can see that in the properties window of Management Studio to see if your giant query, if the optimizer just timed out trying to find a decent plan. And if it does, it often means your query's too big. Yes?
Yeah, I'm definitely feeling guilty as charged in the data warehouse concept because I just grew up with my mentors telling me, oh, don't write procedural code, write a big SQL. And so it's still in the thinking, oh, you can have a part there and you do nice parentheses and it all makes sense and it's a piece of art, 900 lines in the end. Anyway, but I struggle a little bit with it in an ETL concept context. So my idea currently is I have a view which has this ginormous query, and I basically do a set-based approach, trying to load everything into the destination table, and if that fails, I'm gonna go rebar on that view.
Oh, okay.
And could you help me a little bit if I transform the view into, let's say, stock procedure, and I introduce temp tables and so on, and I have a big result set in the end, how would I go about that rebar approach, or I would have to buffer it somewhere else before?
So let's talk afterwards if you want. Yeah, I'd have to understand a little bit more, but that sounds like an interesting example. All right. Almost done here. If these kinds of query rewrites are helpful to you, so like the stuff in this last section, I have a whole nother presentation that I normally do purely about rewriting queries, different ideas, because it's something that the development environment that I'm in, I often do have to kind of come up with these creative ways to write queries to get things to work efficiently. So if that sounds like your environment as well, check out that presentation for more detailed examples. I also have some blog posts and videos about that, going more into detail about what the optimizer is doing in those cases of why it's performing better. So instead of just kind of blindly trying these different things, you could get a slightly better understanding of what's going on. But with that said, right, we kind of went over 5 different anti-patterns today, and I hope that they were beneficial in understanding about how data is moving across the network and how different apps are designed to do different things, even if there's overlap between them. And then how, only looking at a query once, yay, hooray, I got it working, isn't necessarily always the best option if that query is not performing well. So with that said, ending a couple minutes early, but thank you for sticking around for the last session. I appreciate everyone being here, and I'll stick around for questions. Thank you.